ball lightning is one of the most enigmatic and elusive natural phenomena known to science. For centuries, people have reported witnessing glowing, floating spheres of light during thunderstorms. These mysterious orbs have inspired awe and fear, with many unsure whether they were witnessing a natural event or a supernatural occurrence. Despite numerous accounts, ball lightning remains largely unexplained by modern science. In this exploration, we'll delve deep into its history, the scientific attempts to explain it, the potential dangers it poses, and the profound questions it raises about our understanding of the natural world. The history of ball lightning is rich with curious sightings and strange encounters. Ancient texts from different cultures describe glowing orbs that seem to appear out of nowhere during violent thunderstorms. One of the most famous early accounts comes from the 17th century, when British writer and scientist Joseph Priestley described ball lightning as a luminous sphere that entered a room, hovered for a while, and then vanished. Some historical accounts even suggest that these glowing orbs could pass through solid objects, such as windows or walls, without leaving a trace. Sailors at sea have also long reported witnessing ball lightning during storms, sometimes describing the orbs as fiery balls that appeared near ship masts or in the air above the water. In more recent times, many eyewitnesses have provided detailed descriptions of ball lightning. Some describe it as a bright, glowing sphere ranging in size from a few centimeters to several meters in diameter. Its color is usually reported as white, yellow, or bluish, but variations in color have been noted as well. These orbs are said to hover in the air, moving erratically or floating gently before disappearing. In some cases, ball lightning has been reported to last for only a few seconds, while in other cases, it has been observed for several minutes. Although the majority of sightings occur during thunderstorms, there have been reports of ball lightning appearing in clear weather or indoors, raising questions about the conditions required for its formation. While ball lightning has fascinated and mystified people for centuries, scientists have struggled to explain its origins. Various theories have been proposed over the years, each attempting to account for the unique characteristics of the phenomenon. Some of the earliest scientific explanations suggested that ball lightning might be a form of plasma, created by the intense electrical energy of thunderstorms. Plasma, a state of matter in which atoms are ionized and free electrons move around, could potentially give rise to the glowing spheres observed in ball lightning events. However, this theory has faced challenges in explaining how the plasma remains stable and contained in the form of a sphere for an extended period. Another prominent theory suggests that ball lightning may be caused by the combustion of airborne particles or gases. This idea gained traction after experiments in the early 20th century demonstrated that certain chemical reactions could produce luminous spheres resembling ball lightning. In particular, some scientists have hypothesized that ball lightning could result from the combustion of silicon or other materials vaporized by a lightning strike. According to this theory, the glowing orb would be sustained by the chemical reactions occurring as the material burns, producing light and heat. However, this explanation has yet to account for all the observed properties of ball lightning, such as its ability to pass through solid objects. In recent years, advances in high-speed photography and atmospheric research have allowed scientists to capture more detailed data on ball lightning. Some of these studies have supported the idea that ball lightning might be a manifestation of exotic forms of electromagnetic energy. One of the leading theories is that ball lightning could be a form of microwave radiation trapped within a spherical structure, which could account for its glowing appearance and unusual behavior. This theory suggests that lightning strikes could generate intense microwave radiation, which becomes trapped in the surrounding air, creating a self-sustaining ball of energy. While this explanation aligns with some aspects of ball lightning, it still leaves many questions unanswered. One of the most intriguing aspects of ball lightning is the danger it poses. While many accounts describe ball lightning as a harmless spectacle, there are also reports of it causing significant damage. In some cases, ball lightning has been blamed for starting fires or causing explosions. For example, there are documented incidents of ball lightning entering homes through open windows or doors, only to explode with enough force to shatter glass or scorch walls. In other instances, ball lightning has been observed hovering near electrical equipment or power lines, leading to speculation that it could interfere with electronics or even cause electrical malfunctions. Despite its potential dangers, ball lightning has also captured the imagination of scientists and engineers, who see it as a potential source of new technological breakthroughs. If we can understand the mechanisms behind ball lightning, we might unlock new ways to harness or control electrical energy. Some researchers have speculated that studying ball lightning could lead to advances in plasma physics, energy storage, or even the development of new propulsion systems for spacecraft. However, these possibilities remain in the realm of speculation for now, as our understanding of ball lightning remains incomplete. Ball lightning raises profound questions about the nature of our world and the limits of scientific knowledge. Despite centuries of observation and study, we still do not fully understand this elusive phenomenon. Is ball lightning a natural occurrence that can be explained by the laws of physics, or does it represent something more mysterious, perhaps even beyond our current scientific understanding? The difficulty of studying ball lightning in controlled settings has made it a particularly challenging subject for researchers, as its unpredictable appearance and short duration leave little room for experimentation. Some scientists have even suggested that ball lightning might not be a single phenomenon but rather a collection of different events that share similar characteristics. This idea opens the possibility that there could be multiple mechanisms responsible for the formation of glowing orbs during thunderstorms. If this is the case, our understanding of ball lightning may require a fundamental shift in how we approach the study of natural phenomena. Instead of seeking a single, unified explanation, we may need to consider that ball lightning could result from a variety of processes, each producing a similar visual effect under different conditions. In conclusion, ball lightning remains one of nature's most enduring mysteries. From its ancient origins in folklore and mythology to its modern-day study in scientific laboratories, this strange phenomenon continues to captivate and confound. While scientists have made progress in developing theories to explain ball lightning, much remains unknown about its causes and effects. As we continue to explore the mysteries of the natural world, ball lightning serves as a reminder of how much there is still to learn about the forces that shape our environment. Whether through advances in technology, further scientific research, or perhaps even a chance encounter during a storm, we may one day unlock the secrets of ball lightning. But for now, it remains a glowing enigma on the horizon of human knowledge. Ball lightning, despite being one of the most mysterious natural phenomena, continues to provide fertile ground for theories, myths, and even folklore. Its elusive nature, combined with reports spanning centuries and continents, suggests that it could hold clues to untapped natural processes. As we venture further into this enigmatic phenomenon, it becomes clear that each layer we peel back reveals new complexities that stretch our understanding of electricity, energy, and the interaction of forces in the atmosphere. One area of intense interest is the global distribution of ball lightning sightings and whether certain regions are more prone to these occurrences. Historical records suggest that ball lightning has been observed in a wide variety of locations, from remote mountain ranges to bustling cities, but there seems to be a correlation between frequent thunderstorms and increased sightings. For instance, ball lightning has been particularly prevalent in areas known for frequent lightning strikes and severe weather patterns. The American Midwest, parts of Australia, and several regions in Eastern Europe have all seen elevated reports over the past centuries. The relationship between geography and ball lightning could hold important clues regarding its formation, as local atmospheric conditions, such as humidity, altitude, and the presence of metal-rich soils, might all play a role. The unpredictability of ball lightning is another facet of its mystery. Unlike traditional lightning, which follows well-understood pathways through clouds and air, ball lightning seems to defy conventional electrical behavior. While most lightning strikes follow a predictable, almost linear trajectory, ball lightning meanders, floats, and sometimes lingers for far longer than a typical bolt of lightning would. It has been reported to change direction abruptly, move against strong winds, and even climb vertically as if under its own propulsion. This erratic movement has led some researchers to suggest that ball lightning may interact with local magnetic fields in unusual ways, allowing it to defy normal aerodynamic forces. Some have even speculated that ball lightning might involve the interaction of electromagnetic fields and quantum processes, pushing it into the realm of quantum electrodynamics, a field still being actively explored in modern physics. The question of what ball lightning actually consists of remains hotly debated. While early theories pointed to it being a ball of plasma, more recent research has questioned this assumption. If ball lightning is plasma, it would require a significant energy source to maintain its stability, as plasma tends to dissipate quickly without external input. Yet, ball lightning has been observed floating without any visible connection to a power source for several minutes in some cases. More exotic theories have proposed that ball lightning could involve matter-antimatter reactions or even dark matter, two ideas that, if proven, would revolutionize our understanding of energy and the universe. These speculative hypotheses illustrate just how much is still unknown about ball lightning and why it remains such a tantalizing subject for physicists and atmospheric scientists alike. There are also ongoing investigations into the potential applications of ball lightning or the phenomena that produce it. Understanding how a stable ball of energy can form and persist in the atmosphere could open doors to new technologies. For example, some researchers are exploring whether ball lightning could provide insights into new forms of energy containment or distribution. If scientists can replicate or simulate ball lightning in laboratory conditions, it might lead to breakthroughs in energy storage, fusion research, or even weaponry. Ball lightning's potential for energy storage is particularly interesting given humanity's current challenges with renewable energy and battery technology. The ability to store large amounts of energy in a stable form could solve many of the problems associated with intermittent energy sources like solar and wind power. A more controversial aspect of ball lightning is its occasional appearance in paranormal and UFO literature. Because ball lightning often behaves in unpredictable and unusual ways, it has sometimes been linked to reports of unexplained aerial phenomena. In several cases, witnesses who initially believed they were observing a UFO later realized they were seeing ball lightning. This overlap between the worlds of natural science and fringe theories has led to significant confusion and debate. While there is no scientific evidence linking ball lightning to extraterrestrial activity, the sheer number of bizarre encounters with the phenomenon, such as sightings of glowing orbs entering homes, passing through solid walls, or hovering silently for long periods, adds an aura of mystery. Whether these sightings are the result of optical illusions, misunderstandings, or something stranger still is a matter of ongoing debate. Another fascinating area of study relates to the psychological effects of witnessing ball lightning. For many people, seeing a glowing, floating orb in the midst of a storm can be a profoundly unsettling experience, and some individuals report feelings of awe, fear, or even euphoria. In a small number of cases, witnesses claim that ball lightning seemed to interact with them directly, changing direction to avoid them, hovering near them for extended periods, or even following them as they moved. These personal accounts, while difficult to verify, suggest that ball lightning might produce psychological effects similar to those experienced during other extreme weather events, such as tornadoes or hurricanes. The intense visual and sensory nature of the experience might also trigger a heightened state of awareness or altered perception, leading to exaggerated or distorted memories of the event. Recent technological advancements in weather monitoring and high-speed cameras have allowed researchers to capture clearer images and data on ball lightning, though it remains challenging to study. Most documented cases rely on eyewitness reports, which vary in detail and reliability. High-speed cameras and sensors deployed during thunderstorms have occasionally recorded anomalous energy discharges that could be linked to ball lightning, though these observations are still rare. Despite the limitations, modern technology is slowly beginning to provide a clearer picture of what might be happening during these elusive events. Some scientists are hopeful that, as weather tracking technology continues to improve, we will eventually gather enough data to unlock the secrets of ball lightning. In conclusion, ball lightning stands at the intersection of myth, science, and mystery. Its rarity, unpredictability, and potential for danger have made it a captivating subject for centuries. While modern science has made progress in understanding some aspects of ball lightning, much remains unknown, from its exact formation process to the true nature of its energy. For now, ball lightning serves as a reminder that, despite our advancements in technology and knowledge, nature still holds many secrets that we are only beginning to unravel. It invites us to remain curious, humble, and open to the possibility that the natural world is far more complex and mysterious than we might imagine.